Yes, so welcome to this session on the circular economy. We have 5 talks here, and I'll give a quick introduction of some of the speakers here. Marina Pieroni, she's a PhD researcher at DTU, developing tools to promote innovation in circular economy in companies' business models on the Circuit project. Her background is in product service systems and business management. And for 4 years, she was a consultant in industry, including automotive, pharmaceutical, cosmetics, consumer goods, and packaging. And she has a bachelor in chemical engineering from Federal University of São Carlos and a master in process and operations management from University of São Paulo. And the second one, it is the author is listed as Jonas Laurenz Kohl, but actually one of his professors, Michael van der School, is going to present for him. So Michael, can you just give a quick introduction?
Yeah, sure. So I'm from the Technical University of Berlin, and Jonas Kohl wrote a bachelor thesis with me together, and we developed on behalf of our professor, who thought it was a good idea and a good thing in design that hasn't been really talked about a lot. So me and a colleague and Jonas Kohl wrote the paper about social sustainability in the development of service robots, which is my theme that I'm doing a PhD right now about. And my co-author also, Anne Syré, she's in here also. So if there's questions later, she might be helping to answer them. And her specialty lies more on the sustainability of development in the 3 dimensions. So it's like a group of us that did everything together. So I did more the service robot side. She and Jonas Kohl did more the sustainability side of it.
Okay, thank you. And then the third paper here will be Michael Saidani. We're waiting for him to arrive, so we may or may not have him for questions later, but his background, he's a postdoc at University of Illinois, Urbana-Champaign, and his research work deals with implementation of circular economy principles. It seeks to measure, improve, and monitor the circularity and sustainable performance of industrial systems, including technical products and related services. And then our next panelist, who we do have here, is Carolina Villamil Velasquez. She's a PhD candidate at BTH, Sweden, and she's a Colombian industrial designer with a master's in sustainable product service system innovation, with expertise in the industry and academics. And she belongs to the Department of Strategic Sustainability Development at BTH, where they develop products in projects in partnership with multinational companies located in Sweden. And her main research is related to the integration of sustainability in the product portfolio of manufacturing companies. And then our fifth person, who again, not here, but may show up later, is Siyuan Huang, who is a PhD candidate at the Department of Design, Politecnico di Milano in Italy. And the focus of her PhD research is, as you might guess, title, the use or role of metaphor in design for promoting sustainable behavior. So without further ado, let's get to the talks. And so what's going to happen for those of you who've not been in a session yet, we're going to play all of the talks back to back, and then we'll have one big Q&A session for everybody at the end. And so right now, we will go to the videos. Nicola, can you hook those up?
This presentation refers to the paper defining the requirements for a tool to support circular economy business model innovation within manufacturing companies. This is Marina Pieroni speaking, and this article was co-authored by Professor Tim McAloone and Professor Daniela Pigosso from the Technical University of Denmark. To support the transition from linear to a circular economy, disruptions are required not solely in technology or product design and innovation, but as well in business models of companies as a way of promoting changes to the core of consumption systems and operations. Manufacturing companies have a critical role in changing business models to circular economy due to their relevance concerning usage of materials and energy, generation of byproducts and waste, and potential influence to define the product's life cycle. However, no more than 5 to 10% of revenues coming from manufacturers are associated to circular business models. One of the most pressing challenges impeding the broader dissemination of circular business models within manufacturing companies is a lack of knowledge to design circular business models and manage uncertainties regarding economic value creation and operational complexity. This research tries to fulfill this gap by developing a tool for business developers, sustainability or product managers within manufacturing companies that aim to strengthen proposals of circular business models based on an existing scope, for instance, a selected product or an initial business model idea. The tool was developed based on the design research methodology. In a first descriptive study, a systematic literature review of several approaches to design circular economy business models enabled assembling what could be potential requirements, theoretical requirements for such a decision supporting tool for companies. And based on those requirements, initial hypotheses were detailed for practical validation. Based on the theoretical requirements, the key characteristics of the tool were specified and developed into a low fidelity prototype. In a descriptive study 2, the low fidelity prototype was evaluated with real manufacturers from different sectors, and new practical requirements were identified, complementing or highlighting the importance of the previously defined theoretical requirements. Based on the pool of theoretical and practical requirements in a final prescriptive study 2, the final characteristics of the tool were specified, and finally, a high-fidelity prototype for the tool was developed. The research presented here shows 3 key results that emerged. First, a collection of 22 requirements distributed among theoretical and practical requirements, describing the way the tool was developed, the usability and application characteristics expected, and the content of the tool. For example, it was a requirement that the tool should focus on the specific manufacturing sectors, developing different types of circular economy business models. Second result was the collection of functionalities and the overall architecture for the tool that was developed in the format of an expert system containing 4 modules. And the final result was a high-fidelity prototype developed in Excel with the 4 modules. After the publication of this article, the high-fidelity prototype was evaluated in an independent application with 10 different companies from different sectors and 7 academic experts. This evaluation enabled collecting evidence that showed that the expert system was able to provide a source of inspiration for best practices in circular economy business models to manufacturing companies. As well, it provided guidance on the overall process of business modeling and enabled the companies to increase their articulation, to develop the proposals, and especially to estimate the potential of the circular economy business model ideas. Since the expert system was developed to be customized to specific sectors, a potential limitation that was identified was that the application boundaries of the systems could have been restricted, and further exploration with several types of manufacturing companies are necessary to refine the boundaries of application.
Okay, and just a quick little note before we get into the second presentation here. I forgot to mention that you are all highly encouraged to ask questions and actually type them into the chat box during one of these videos, because otherwise, you know, it can be hard to remember what questions you have 3 videos later once we get to the actual chat session. Because all the questions are going to be all together. So, so yeah, don't be afraid to interrupt the video because it's just in the chat, and don't be afraid to ask any questions. There are no stupid questions. We want as rich a discussion as we can get. So, so yeah, so feel free to just type questions into the chat. I'm gonna just model that here by typing a question in, and I'm not going to ask Marina to answer this now. We'll wait till the end, but just to show you that it's okay to type questions in there. Okay, let's go to the next video.
Hello everyone, and welcome to the presentation of our research paper, Social Sustainability in the Development of Service Robots. My name is Jonas Kohl, and I will present this paper on behalf of my co-authors Michel, Joop, Syré, and Dietmar Göhlich. Our research looked at the emerging field of service robotics and the impact it might have on our society at large. We particularly considered the increased ubiquity of autonomous machines in the workplace and the public urban context, and the frequently made demand to consider the different aspects of sustainability, generally identified as the ecological, the economic, and the social, as interdependent and equivalent. Realizing that social aspects of sustainability are rarely addressed and operationalized in the existing literature on this topic, our goal was to develop a guideline that can be consulted in the context of an automation project to assess the effects that the desired product or process would have in this regard. To explain what motivated our research, we have to look at current trends in the robotics industry, where we see service robots steadily increasing their market share. With new advances in artificial intelligence, the prediction that service robots will play an ever-increasing role in our day-to-day lives stands to reason. Countless new research and development projects offer a glimpse at how such a future might look like. Small autonomous last-mile delivery robots, collaborative street cleaning robots, and assistant nurse robots are only a few examples of the many novel applications imagined for automation technology. In all of these examples, we see a transformation of established systems, be it our immediate surroundings, our workplaces and tasks, or our experience of services and care. Any benefits are to be expected here, but the corresponding risks naturally should not be neglected. While some disruptions may remain minor, we argue that a fair amount of precaution is advisable when it comes to changes to established socially organized systems. We looked at relevant prior work and found that many established frameworks, such as the eco-design tool by Katwinkel et al., solely focus on ecological sustainability. Buchert and Stark advocate for the inclusion of all 3 aspects of sustainable design, but give a limited description of social sustainability in their publication. Building up on this, we identified key social issues relevant to the service robotics sector. Our analysis was based on the concept of social life cycle assessment, and with regard to Schulte and Hallstedt, it understood social sustainability issues in terms of risk management. Hence, we wanted to create a warning system that would help to detect risks and locate the most relevant social issues as early as possible. Here you can see a complete list of the key issues we were able to identify. We clustered the effects into 4 groups. Each row represents an aspect of a hypothetical automation project that can strongly affect social sustainability. The identified key issues are as follows: loss of employment, repositioning, monotonous and mentally straining tasks, dangerous or physically straining tasks, losses in position and task quality, polarization of qualification levels, ethical complications and responsibility issues, loss of socially valuable services or human contact, creation of hostile environments, and a decrease in accessibility or equal opportunity. Of course, not every one of these points will be relevant to every possible automation project. Here in the columns, we included a key to assess the relevance of each individual issue to a given project based on a specific characteristic of the latter. It should be emphasized that we included a category in some cases where a specific issue can likely be improved through an automation instead of exacerbated. We also gave some preliminary suggestions on how to evaluate the impact of the specific issues and assess the degree of interdependency of each issue to the other sustainability aspects all the way over here to the right. To illustrate how to utilize the introduced guideline, we applied it to the automation project Murmel, currently developed by Michel, Joop, at TU Berlin. Murmel aims to improve the process of emptying litter bins in an urban environment, mainly by means of automation and replacing fossil fuel engines. Beside the initial goal of improving the ecological impact, however, this project clearly affects social sustainability. So here you can see how the guideline is applied. We use a radar plot to give a broad sense of the most relevant issues at hand. Each axis represents a specific issue with the concentric rings corresponding to the levels of applicability or respectively urgency. The more urgent an issue, the further the graph gets from the center, thus increasing the plot area for the corresponding effect group. In the case of Murmel, we identified effect 2.1, monotonous or mentally straining tasks, as the most pressing issue, while dangerous or physically straining tasks were deemed as unproblematic due to the fact that this task group is actually reduced here. The application of our guidelines led to some adjustments of the project. As an example, the assessment that led to the area concerning effects on work becoming comparatively big resulted in a shift in focus away from full automation and towards human-robot cooperation. It should be stated that the method we propose is at a quite early stage. We consider our work to be an early step into an insufficiently explored field of research. Further application of the guidelines to specific projects will not only support product development, as we expect it to improve the quality of our method as well. Finally, we propose that similar endeavors in the broader field of automation technology in other sectors are necessary to ensure a holistically sustainable future. And with this, I say goodbye and thank you for your attention.
Hello, my name is Michel Saidani. In this 5-minute video, I'm going to discuss and illustrate how circularity indicators can be used to design more circular and sustainable products. It has been increasingly acknowledged that circularity indicators are key to monitor and catalyze the circular economy transition. Meanwhile, circular design is central to effectively close the loop on products and materials. Here, we will focus on how product-centric circularity indicators can be used to guide product design to increase circularity and sustainability performance. Actually, the positioning and proper application of such indicators during the product design and development process still needs to be further investigated in order to foster the appropriate uptake in the new development or redesign of products. Specifically, we will try here to bring new insight on, first, how these recently developed circularity indicators and associated tools can be complementary to existing eco-design tools, and second, what is their positioning within the extensive pool of methods and tools aiming to mitigate the environmental footprint of products. To do so, the present research work combines, first, a review of the latest publications focusing on C indicators at the micro level of circular economy implementation, second, an analysis of these C indicators in the light of their application during the design and development process of products, and third, a workshop experimenting several circularity indicators on an industrial products with the aim to augment its circularity performance through design improvements. Here is just a rapid overview of relevant previous works. On the left, a summary of numerous eco-design tools and methods reviewed by researchers and classified along the design process. On the right, a snapshot of the increasing numbers of circular economy indicators recently developed. To bring new practical insights on how circularity indicators can be deployed to guide and support the generation of eco-improvement, a workshop has been conducted with doctoral students in eco-design. Each group of 4 PhD students were experimenting 2 circularity indicators on the same products to first evaluate its circularity performance and second, to propose eco-improvements on this basis. The information related to this case study and provided to the participants was synthesized in a 2-page document, including the industrial context, a simplified version of the catalytic converters with information on its pre-life, usage, and end-of-life. A pre-filled response document for each circularity indicator was also given to the participant. The 4 circularity indicators illustrated here have been tested. They have been selected because they fit with the requirements of this case study. Also, these 4 circularity indicators are coming with an open access computer-based assessment tool, whether a dynamic spreadsheet or a web-based tool, which makes the calculations more manageable, whereas other potentially relevant indicators are not directly accessible or are only embodied in a textual format. Based on observation and new feedback provided by the participants, these 4 tool-based circularity indicators have been mapped on the engineering design and development process and positioned among the pool of main eco-design tools. It has been found that the 4 circularity indicators experimented are time efficient. In fact, the assessment can be done in less than half an hour with sufficient data and do not require a high level of expertise to be properly used. Note that the MCI only requires a few input and is best used to quickly compare and select mature alternatives, as well as a communication and benchmarking tool. The list of questions to compute the CIT, CPI, or CEIP can be used to define circularity-oriented requirements, and the circularity scores can be used to rank and identify best designs, as well as to monitor product circularity. Also, feel free to check out our paper to see concretely how such C indicators can be helpful in the generation of solutions to improve the circularity performance of products. Before wrapping up this presentation, here are 2 promising lines for future research. The first one is on how to foster the adoption of such indicators and tools in industrial practices. The second one is on the connection between circularity and sustainability scores to systematically make sure a circular design is profitable and environmentally friendly on the long run. Thank you for your attention, and feel free to reach out if you have any questions.
Welcome to this presentation, How can information and communication technology support the link between circular economy and product lifecycle management? This study has been done by me, Carolina Villamil, Niloufar Salehi, and Sophie Hallstedt. We have seen that many manufacturing companies still have linear processes. If they want to be more sustainable, they can include in their system more circularity, where they are more effective and they don't have any waste in the processes. That's why circular economy can be a good approach. As well, we have seen that many products are using many sensors to collect a lot of data. So with this study, we wanted to see if it's possible that ICT support the link between circular economy and product lifecycle management. This is a systematic literature review where we wanted to see the different opportunities and limitations to use ICT for the circular economy transition in the different stages of the product life cycle. So we are going to see the different stages of the management. For example, in the beginning of life, in the design and production of the product, it's possible to collect data to improve the efficiency in terms of energy and resources, and as well it's possible to improve the design to be easy to be disassembled and for remanufacturing. In the medium of life, in the use phase, it's possible to collect data to improve the service and to see if the product needs to be maintained or repaired. In the end of life, it's possible to track the different materials and determine what is the real quality, that those materials can be recycled and used in another manufacturing processes. So with this study, we identified the ICT supports the transition to circular economy in different aspects, like one, in the design, because it's possible to find different scenarios to improve the product and be more effective in sustainability terms. As well, it's possible to create new business model when you can propose a new value of the product. And as well, you can improve the process and operations of the system because you can close the loops and have a better value chain management. We as well identified the active and the passive role of ICT. Like for example, in this washing machine, in the use phase, the company can collect a lot of information about the efficiency of the product. If the product is not completely efficient, they can change immediately and be more efficient. That's the active role. For the passive role, the company collects information at the end of life. So this data will be used for the next generation of products. As well, we identify that the system perspective that that provides the ICT is good for the circular economy because it provides data of all the stages of the product life cycle and as well increment the collaboration between the external and internal stakeholders. As well, we identified that it is important to define what is the real purpose of the ICT devices. For example, they put a sensor in this racket, but nobody was really interested in the data. There are several challenges, like you need more infrastructure, logistics, resources, and as well, from a sustainability perspective, these ICT devices create more e-waste. Here you can see the increment of e-waste from 2010 to 2018. As well, a lot of this electronic waste is sent to other countries when they have low regulation. As well, these ICT devices are manufacturing with critical materials that in the future will have a very low supply and it will be problems to get these raw materials. As well, they are related with conflict minerals when they have child labor, human rights violation, and war. In conclusion, ICT supports the transition to circular economy, but you need to really understand what is the purpose of these devices because you don't want to create more sustainable products that really they solve. Thank you.
Hi everyone, I'm very happy to attend the Design 2020 conference and introduce you our research paper entitled Designing Product Metaphor to Promote Sustainable Behavior, a Proposed Method. Nowadays, although many people have expressed concern about environmental issues, but at the same time, many people still are living in unsustainable ways, which has a great negative impact on the environment and society. Since the last decade, increasing attention has been placed on the mediating effect of products and systems on human behaviors, which marks an emergent field, design for behavior change and design for sustainable behavior. However, in literature, limited attention has been given to the connection between behavior change strategies with design idea generation and communication. Therefore, our study proposes a metaphor-based design method to guide designers on how to associate product features with behavior cues in product design to promote sustainable practice. First, the essence of metaphor is understanding one thing in terms of another, which shows the advantage of metaphor to express and clarify abstract things through meaning transfer. For instance, this phrase, "I have butterflies in my stomach," describes a sense of tension and excitement through the use of figurative representations in people's daily lives. Apparently, metaphor can help people construct the meaning of abstract things. Later, the meaning generated can also open up new avenues for human experience and behavior. In this example, the listener may wonder how to ease the speaker's burden by capturing and getting rid of the butterflies. Second, conceptual metaphor plays an important role in UI design to guide user behavior, such as waste bin for file deletion and an envelope for the mailbox. Besides, the use of metaphor in product design to stimulate certain behavior is not uncommon. For example, a net capture-shaped trash bin was implemented along the highways to reduce littering. By transferring the characteristics of the trapping net to the trash bin, the metaphor created in these products can generate new meanings to the existing behavior of waste disposal. This case perfectly illustrates the concept of product metaphor, which is defined as any kind of product whose design intentionally references the physical properties of another entity for specific expressive purposes. So, to leverage the power of metaphor in behavior design, designers should establish a meaningful connection between the user's previous experience with the materiality of interactive artifacts. Here, due to time constraints, I will not introduce this method in depth. For more information, please check out our paper. As an application of the proposed method, here we present a case study, which is an interactive food tray designed to reduce household food waste. As you can see, the main product metaphor we created in this design is the spatial schema of tree leaves, because abstract concepts contain sensory motor simulation of bodily states. An orientation metaphor like the downward movement of the branch can refer to sickness, bad condition, and the end of life. Through this metaphorical mapping, users can easily compare the freshness of different fruits and decide which one to eat first based on the relative height of the food tray. It is worth noting that people from different backgrounds might see things differently. In this case, a comparison between top-down and the bottom-up movement of the food tray is worthy of further investigation, because some people tend to pick up the food when it is close to the body, like a waiter serving a plate, while others think the foods kept in low position means they are mature and edible. Therefore, when applying metaphor in design, we must pay close attention to the differences in human understanding. In addition, our paper also includes another case study. If you are interested in it, please check out our paper. Through the application of the proposed design method, we can conclude that metaphor does have many advantages in design for sustainable behavior. It can help designers envision meaningful human-product interactions during the design conception stage. By constructing product expressions, it can also promote the communication between designers and users and make people better understand the behavioral cues in design so as to behave in desired ways. In summary, metaphor in design should be handled with care. Here, we outline the possible directions for future development. For more information, please check out our paper. Now it's time to bring this presentation to a close. Please feel free to contact me if you need any further information. Thank you.
Okay, so that was all 5 presentations here. Now, it looks like we still don't have Michael Saidani or Siyuan Huang on the call. Just double checking, is that correct? Or if you have snuck in and I haven't seen you, say something now. Okay, so probably not. And so, Yann, are you able to speak for Michael? No? Okay. Okay. So yeah, it looks like in the chat you are. So yeah, and I mean, we can direct more questions towards other people if you want. Is there anyone here who's affiliated with Siyuan Huang, the last presenter, who might be able to answer questions on her behalf? Okay, sounds like no. But yes, Yann, let's get you on the audio so that you can answer questions. Yeah, if you just click the button for asking to share audio and video, we should be able to let you in. But okay, just to get things rolling here, and I see there are more text questions coming in, which is great. So let's get started. And I think we can start out with a question for Marina, since she was the first person. And I saw that there was a question in the chat from Sebastian Wolf. Sebastian, do you want to connect to audio and video so that you can ask the question in person, or would you prefer me to read it off?
Can you hear me?
Yes.
Okay.
Go for it.
So yeah, apparently I prefer the video option. Let me just scroll up to my question. Thank you for your presentation, Marina. I was wondering if it would be possible to evaluate product as a service or mobility as a service, something like car sharing or systems similar to car sharing, to evaluate their sustainability with your tool, because I think, as you mentioned, the car sharing system is very sustainable, but the mobility system is not. So I was wondering if it would be possible to evaluate product as a service or mobility as a service, something like car sharing or systems similar to car sharing, to evaluate their sustainability with your tool, because well, my background is from automotive, and we were discussing the connection between sustainability and product as a service, mobility as a service systems. So your tool would be really interesting for that question.
Yeah. So partially, my answer to you will be partially, and depends on up until what extent of sustainability and how you want to assess it. So regarding whether you can use it for product service systems, yes, which I presented here. It is focused on specific sectors. Mobility, as automotive part of mobility is not on focus in the tool, but we do have heavy machinery where there are solutions for industrial trucks that could look very similar to the automotive, of course, with some adaptations, because it deals more with B2B instead of B2C, like you would have in the automotive. So you could get inspirations from there. So if you get to use the tool, I would recommend that you select the sector heavy machinery. You can get inspirations from, for instance, how Caterpillar is dealing with the product service systems, and that could have some sharing concepts or there as well. So I think you could still use it. But the second part of your question, to assess the sustainability. So the tool is very focused on circular economy, the quantitative part on evaluating circular economy perspectives within sustainability. So it doesn't look quantitatively on the social gains of sustainability. And even within the environmental assessment, it builds on a much more comprehensive tool from a colleague of mine. Then I would recommend this tool, and she will have a presentation here as well. I think it's tomorrow. My colleague is Maria Kravchenko. I'll send to you the tools. In her tools, you could evaluate all the comprehensive view of sustainability. But in this tool that you have there in the configurator, you can evaluate resource decoupling with some leading indicators, like what is the potential for increasing longevity of the cars or the products? What is the potential to increasing utility? Because basically I've learned with Maria's tool and just incorporated 8 of the indicators. In the full tool from that Maria developed with Tim McAloone and Daniela, they have several indicators. So I would recommend that you can start in this one and maybe go for a more comprehensive sustainability evaluation in the second one. I'll send you the second tool. Okay. The second group of tools. Is that enough? Or do you have further questions?
Yeah, I think so. Due to the time, I think I would leave room for the other questions. Maybe I can just write you a direct message or something like this.
Yeah, sure.
The others have some time for their questions as well. Thanks.
Yeah. But I am noticing that something that I appreciate about the virtual format of this conference is people's ability to just throw links in the chat box to share things with people. That is kind of a nice silver lining here. But yeah, let's get a question for one of the other presenters for Jonas's paper, since Michael is here for him. Marina, you had a question for Michael / Jonas. Do you want to ask that?
Yes, my question would maybe touch in the broader aspects of what this work can deal with, and it's more thinking outside of the purpose for what the work was developed. Like if we think about digital platforms or other types of business, not related to technology, like related to social media, it's very polemic because this type of businesses, they make a lot of money, and maybe their potential to distribute wealth is limited when we compare to technology producers or manufacturers. So I just would wonder if that framework could be used for assessing as well the wealth generation potential and distribution.
Yeah. I think the problem is that we aim to, or that we made this table mainly for services, especially the one case that we're showing is for the municipal waste management in Berlin, which is from the state, so not a private owner. And this, I think the social media you're talking about is designed to have few jobs. And that's not really what we aimed for. We're looking at places that provide services to society that have a lot of jobs and that might be, how do I say it, getting more stressed by like increasing population. There's going to be more waste, stuff like that. So there needs to be a shift maybe towards more efficiency through automation. That's the kind of theme that we're looking at. Not really the what you said, social media, where you have few jobs and a big income. But I'm not denying that maybe this could work, that you could maybe think about also jobs, not only developing techniques or machines, but also jobs that, I don't know, in some way could be more social sustainable. But yeah, we haven't focused really on that. So interesting question. I will think about it.
Yeah, I think I'd like to poke you a little more on that same topic, actually, because I think that the places that are most likely to adopt robots to automate things are places where labor is expensive, not places where labor is cheap, where there are, places where labor is cheap is where there are lots of jobs. And with labor being expensive, then you get fewer jobs of higher skill. So how do you even calculate? This is a curious thing when I was seeing it. How do you even calculate or estimate the number of jobs that will be lost from robotics versus the number of higher paying skilled jobs for robot makers or maintainers or things like that?
I think that is a really tough question. I guess you have to look at the job where you're looking to implement such a automation initiative. For us, it was like, it is the waste collecting or the bin collecting. And you can clearly just get at the statistics how many people work in that field at the moment, how many hours are they doing, and then we try to design our robot and think of what he can do, so what kind of workload he will take away from them. And that's probably how you could try to level or see what impact it could have. And if that impact is, for instance, also saying that we could create other jobs by it, we have to really look at the impact that we're not in a minus or negative losing jobs, but maybe keeping the same amount of jobs, or trying to also the quality of jobs not make it more strenuous than it is right now. So it's like a risk management, as Jonas said it, to evaluate your idea in terms of impact on the social sustainability.
And let's get a question for the next paper, which Yann, do we have you successfully on audio now?
I think so. Can you hear me?
Yes.
Yeah,
Okay,
I'm very
good.
sorry about that. But I try to answer your questions.
Yeah, no, that's all right. So actually, we have a question from Daniela in the chat. Daniela, do you want to hop into audio, or should I just read off your question? Let's see. Since I'm not seeing an audio request, I'll just read her question off. She's asking, could you please reflect on the disadvantages of using the MCI when measuring the circularity of products?
Yeah, I can try, but the main drawback is not the way to use the MCI to measure the circularity of products, but more the amount of information, the level of details, the amount of knowledge which is required to assess the product circularity. I guess this is the main drawback. And finally, the conclusion is that maybe this tool is not adapted for assessing products at early stage of development. We're more focusing on conceptual design, where degree of freedom are very high, and the information is not sufficiently detailed to capture the nature of materials, the capability to recycle or reuse these kind of materials. But well, if we have the amount of information, might be a good tool to assess this circularity.
Okay. Thanks. And actually, I'm curious. I'll throw on an extra question there. There are a lot of circularity indicators nowadays. Is there do you think there's a good taxonomy out there for, or chooser chart for, like, when you would want to use this circularity indicator versus that one versus this other one? You know, what their strengths and weaknesses are?
I don't know. I think there are a lot of tools, as you said. We can find maybe 3 to 5 big taxonomy, but sometimes it's quite difficult to navigate into the different tools. But this is the core of the work of Michael's. Try to facilitate this navigation into the circularity indicators according to the audience, the time consuming to perform such assessments, but also the kind of decision making.
Okay. Thanks.
Thank you.
And then let's get to Carolina. So we had a couple different questions for you, although one of them might have already been answered by text in the chat. I'm not clear about that.
Yeah, one of the co-authors already answered one of them.
Okay. Okay, and that was Sebastian's question, right?
Yeah, definitely. But I can add a little bit about that if you want.
Sure, let's go for it.
The thing is that you were asking, like, the kind of data, like you can collect a lot of different kind of data, but definitely you can focus a specific data that can be used to close the loop or maybe improve the quality of the product, so you can improve the life of the product and make it be longer in use. So that would be beneficial from a sustainability perspective, of course, but we didn't do a differentiation of specific data because it was too much information, and we wanted to focus more in the advantages and in disadvantages of using ICT to support the circular economy transition. So,
thanks.
Yeah.
And then I'll go on to Daniela's question and add just like a little bit more. So she's asking for a reflection on the potential downsides of IT for the circular economy, and you just mentioned that they exist. So how do you balance things specifically, like if you're adding electronics to stuff that products that didn't have electronics before, suddenly they're a lot harder to recycle, and there's a lot more embodied energy and toxic chemicals and material depletion, stuff like that. So how do you model when it will help versus when it'll hurt?
Yeah, we found out a little bit of that in the literature that we review, but it's not really a specific way to say is in this direction. I think that the workshop that we were having yesterday about these trade-offs, I think that is more focused on how to think about what is the best solution. But from my perspective, when I was doing this review, I saw that many of the articles were focusing in the advantages, but they most of them, they don't recognize. It was very difficult for us to find the disadvantages of using ICT. We have to be in another literature in order to identify and do the connections. For example, this rebound effect, or maybe the thermodynamics law. When you use, do you need to use more energy or more materials in order to do this kind of approach? Like if you, as you say, you need more electronics, or you need more logistics to deal with all this data. So sometimes you have to put in, as you say, to put in the balance. It really is a very beneficial from the sustainability perspective or not, because as you say, maybe the environmental impact is going to be higher when you have the end of life, when you have these different kind of devices, ICT devices, and it's not possible maybe to reuse them, or maybe not possible, they are so small that maybe they are not possible even to identify where are being the product. So that can be as well one of the big trade-offs, but we haven't analyzed this that further, because as I told you, the literature usually don't focus on these trade-offs. They focus more in the advantages.
Yeah, and I think that's a real shame. I think somebody really needs to do that. I know that nobody wants to be the grumpy person saying like,
yeah, but I doubted that a company will pay for this. Like a company will not pay for something like, we don't want to pay that they say that this is bad.
Yeah, exactly. But yeah, seriously, someone has to do that, and so that we can figure out what the boundaries of this are. Yeah, so I do think that'll be really important.
Yeah,
and
definitely.
yeah, and so so we just have a couple minutes left here. So I don't know. Do any of you presenters have any other questions for each other? Maybe time for one last question or two last questions. Silence. Well, okay. Oh, go ahead, Marina.
No, you had a question. You put a question to start warming up. To me, you said how you come up with the 21 criteria for the business evaluation.
Yeah.
Whether there was some kind of cut. So the 21 criteria came either from literature review or then through validating them with companies. And the cut was more in cutting things that could be overlapping or merging them. But we didn't have to really exclude something because they are more in a higher level. It's not that detailed. So yeah, that's the answer. Okay.
Cool. Thanks. And did you find that there was a lot of overlap between those criteria and things like, I don't know, Tucker's map of product service systems, his like little taxonomy of those, or were they separate, or things from like business model canvas, or yeah?
Yeah. So those are not these requirements that I'm talking about, because those are more like the content would just say you have to provide recommendations. And then that's a requirement. And for the recommendation, we had to identify which framework would be part of the recommendation. Then it was about deciding on how to choose one or the other. But there's a lot of overlapping of those available tools, such as Canvas, or as you were mentioning, the archetypes as well. There were different ways of addressing them. And we did a job of synthesizing, yeah, as well.
Cool. Yeah, I know it can be hard to like untangle lots of overlapping criteria, and you want to shrink them down as much as you can, but not leave anything important out. Okay, well that's so we only have 1 minute left.
Maybe
so...
one question.
Oh, yeah, go ahead.
For the presentations, are they available somehow for a review to look at it again, or is there any?
Good question. That would be a question for Nicola. Can you tell us?
Yeah, thank you, Nicola speaking. Basically, all the recorded sessions, the sessions are recorded and they will be available to you after the conference. Yeah. But like, we'll notify you through
Cool.
via email or on design webpage, design conference webpage, where those sessions will be. Yeah. Okay.
Okay, thanks a lot.
Great. So yeah, so that is exactly time. So I think that worked out perfectly. Thank you all for thank you all who presented for talking about your work and the good research that you've done. And thanks everyone else who participated and had interesting questions. And yeah, hope to see you more through the rest of this week.
Jeremy, thank you everyone.
Thank you, Jeremy.
Bye bye. Thank you, Jeremy.
Thank you, Hal.
Bye.